So I hope you all are fine. I'm Natasha and welcome back. So today we're going to continue our chapter 1 and that is sets. And so in the previous video, we discussed about the components of sets. And in this video, we're going to, discuss about some practical problems on intersection, and union of two sets. So, whatever I can say, practical problems on union and intersection of sets, that doesn't matter. Okay, so first of all, like in the previous video, we discussed about components of set. And in components of set, those kind of sets, like those, who belongs to universal set, but they actually do not belong to the given set. That's what it is all. That's what it was all about. So soon we're gonna do practice questions on our today's topic and on components of sets also. So let's get started with our today's topic. Okay, so practice. It's not actually practice. It's actually practical. The practical problem. So let me write it. It's practical, not practice. Practical. Okay, so we're gonna go through some practical problems, related to our daily life. So, why do we need to focus on these problems, like the practical problems on union and intersection of two sets? So let's say that what if we have to find, in case what if we have to find the number of elements in a set? I can say in a set, or in a set, that's different, but we're going to talk about the intersection, of sets. So what if we have to find the, number of elements in, intersection of sets, intersection of two sets, or in the in the union of two sets. So that is what, we're going to have a look at some things, okay? So, so that we can find out the, number of elements, so let's say we have two sets, set A and B, as usual. These are the common sets. So, okay, so let's get started. Okay, so first of all, let's say that, okay, so let's set A and B, let's set A and set B, be finite set. Okay, you already know about finite sets, so, and there's one thing, that A intersection B is equal to phi. Then what are we going to do? We have to find the number of elements in A union B. So A intersection B is equal to phi, but A union B is equal to what? We don't know about it. Okay, so in the first, in this first case, so number of elements, so in A union B is equal to the number of elements in set A plus the number of elements in set B. So this is gonna be our first method. Okay, so the first thing that we're gonna notice. So what's in difference? So we're just letting set A and B be finite sets. Okay, we're just letting them to be finite sets. Okay, they're actually not finite sets, but yeah, just let A and B be finite sets. Okay, and A intersection B is equal to phi. So how did this come? So actually, we can already see that A intersection B is equals to phi. And there's a Venn diagram. It is also, I can also show you in the Venn diagram. Okay, so it's going to be this way. So we have two triangles, okay? This is going to be A minus B. This is going to be B minus A. And this one, which is right in mid, this is going to be A intersection B. Okay? Got it? And, this is going to be our universal set. Okay, so as we can see that, actually, A minus B, B minus A, and A intersection B are actually disjoint sets. And you know what? And and their union is going to be A union B. Of course, like it's going to be A union B. And so A minus B, B minus A, and A intersection B are going to be disjoint, and their union is going to be A union B. Like, why did suppose it? Okay, so we in the first case, like we let set A and set B be finite sets. But what if we I'm going to say that in general, set A and B are finite sets, okay? Then what are we gonna have a look? Like, it's really simple. So the number of elements in A union B is equal to the number of elements in set A plus the number of elements. Oops, let me write it again. Yeah, so it's actually going to be, so let me just say, number of elements in set A. Okay, so let's continue. So the number of elements in set A plus the number of elements in set B minus the number of elements in A intersection B, okay? We're taking the same case. So this is going to be a third case, okay? So in this one, what do we notice? It's it's simply, let's just say that A intersection B was on different side. It's it was on left side, and 5 was on right side. So we just can simply say on shifting its side. Of course, we're gonna get negative. So if something is positive, we're gonna shift it on the other side. Of course, it's gonna be negative. So number of elements in A union B is equal to the number of elements in set A plus the number of elements in set B minus number of elements in A intersection B. Just have a look at these two cases. These are some methods. We're going to use the second one, and I'm going to show you that how they are useful to us. Okay? Yeah. So let us continue. And now one thing I want to tell you that in the first case that we saw that number of elements in A union B is equal to the number of elements in set A plus the number of elements in set B. So what does this actually means? So it is just trying to say that elements in A union B are either in A or in set B, but not in both, as but not in both, as A intersection is equal to 5. So you know what? So it's going to be either in A or in B, but not in both. Because, as A intersection B is equal to 5, which means an empty set. That is why. So, and in general, we take that A and B are finite sets. So in this case, we have included, so in A intersection B, so in the third one, we can see that A minus B and B minus A and A intersection B, these all three are what? These are actually disjoint. They're actually, they're actually disjoint sets, and their union is going to be A union B, their union. Is it clear? Just have a look. So these all three are going to be the disjoint, and their union is going to be A union B. Got it? Okay, so let's continue. Okay, so what I'm just simply trying to say is that whatever we have is, okay, so now let me just use it in a formula, to find the number of elements in A union B. Okay, so the number of elements in A union B is equal to what? Number of elements in A minus B plus the number of elements in A intersection B plus number of elements in B minus A. Okay, let's have a look. Okay, is it clear? The next step, what are we going to do? So we're going to just simply, write it twice. Okay, so n, number of elements in A minus B plus number of elements in A intersection B plus number of elements in B minus A plus number of elements in A intersection B minus number of elements in A intersection B. Got it? So this is going to be like this long, this much long. So in the first we had number of elements in A minus B plus n of A intersection B plus n of B minus A, and then we just repeated that pattern. So number of elements in A minus B plus number of elements in A intersection B plus number of elements in B minus A. And then we're gonna, we took their positive and negative both. So the plus the number of elements in A intersection B plus, or now it's gonna be negative. So negative will like minus number. So negative number, the number of elements in A intersection B. And after that, after solving it, at the last we're gonna get something common. Something really common, and you'll be like, what, really? So then the last we're gonna get, after whole solving it, we're gonna get n of A plus n of B minus n of B minus A. Got it? So this is what in the last we're gonna get. So this is what it means. So and n of A, so number of elements in A union B is equal to this. This is mainly a method to use to find out the number of elements in A intersection B, or it can be also A union B. Okay, so this one expresses our second one. The second one which we had right here, isn't it? Okay, so let's move on. So it verifies our second one, which we can see by solving it. So this is what it is. So for you'll be a little bit maybe confused. You'll still be a little bit confused, but don't worry, we're gonna take examples so that all our doubts or whatever the confusion is going to be clear. Okay, so this actually not expresses, but yeah, this actually verifies. Whatever you can say, but it actually verifies. So this is actually verifying the second one we just discussed about it. So it verifies the second one which we have right here. And so let me rub this side to so that I can write the example. Okay, so the question is, if X and Y are two sets such that X union Y has 50 elements. Okay, so if, let's say question if, if X and Y are two sets such that X union Y has 50 elements, and X has okay, so I've written the question on the notebook, so I'm just writing from it. So X has 28 elements and Y has 32. X has 28 elements and Y has Y has 32 elements, isn't it? Yeah. Okay, so how many elements does X intersection Y have? X intersection Y have. So how many elements does how many elements does X intersection Y have? Okay, look at the question. Okay, is it clear? Okay, so let's solve it. So I'm going to solve it. So first of all, we will notice something that, I can say that I think that there are three things, three things are gonna, three things will be given to us. First one is going to be the union of those two sets, and, it can be like, it's going to be three things. So first it can be like the union of those two sets, and there's, the particular set we're talking about, their elements also. So like in this one we have X, so it is saying that X union Y has 50 elements, and X has 28 elements, and Y has 32 elements. So like we have to tell the number of elements in X intersection Y. Like how many elements does X intersection Y have? So we're gonna use this method, because for this we can find it simply. Okay, so just just the place of set A and B, we're gonna use X and Y. Okay, that's it, nothing else. Okay, and if I'm gonna try it and yeah, if without this method, I'm gonna get the answer real quickly. Okay, so just first of all look at it orally. Okay, just have a look at them. Okay, so X union, okay, so it is saying X union Y is equal to 50 elements, and X is equal to 28 elements, and Y is equal to 32 elements. Okay, so first of all, if you're gonna add, okay, yeah, whatever. So we have to find the, what do we have to find? We have to find the X intersection Y. Okay, so in first we're gonna, X union Y has 50 elements, it is clear, and X has 28 elements, this is also clear, and Y has 32. So first we're gonna follow the method and then orally. Okay, so it's given that the number of elements in X union Y is equals to 50, and the number of elements in set X is equal to 28, and the number of elements in set Y is equal to 32. So number of elements in X intersection Y is going to be what? So by using the formula, so this is like a formula, so by using a formula, what are we going to get? So it's kind of really simple. Okay, so yeah, so it's given these all the things, so we're going to just by using the formula, so what do you have to find? So we have to find X intersection Y, which is going to be on right, left hand side. So number of elements in X intersection Y is equal to the number of elements in X plus number of elements, not again. Okay, I'm gonna rub it from hand. Yeah, plus the number of elements in set Y minus number of elements in X union Y. Okay, so whatever we have to find, we're gonna write its opposite to on the right hand side. If we have to find intersection of two sets, we're gonna we're gonna write the union of those two sets on the next side. Okay, so it's it's a negative, so remember it's gonna be negative. Okay, so next one is that number of elements in set X is 28 plus number of elements in set Y is equal to 32, and the number of elements number of elements in X union Y is 50, isn't it? And the same, whatever. Okay, so now after adding them, what are we gonna get? So we're going to get let's say this is gonna be 8. Okay, sorry. Yeah, so 8 plus 2 10, and 3 plus 3 60. 60 minus 50 is equal to 10, isn't it? So this is what the number of elements in X intersection Y will have. So what I'm going to say is that the number of elements in that x, x intersection y is equal to 10. That's it. I just added them, like the sum of 28 and 32 is going to be 60, and 60 minus 50 is going, is going to give us 10, and that is what? So the number of elements in x intersection y is equal to 10. So like to check it, we can, suppose we don't know the, the value of x, like we don't know the elements of x union y, and we have x intersection y is equal to 10. So how can we find it? So first of all, like following this formula, just, I'm going to write here x union y, and here x intersection y, okay? And then I'm going to write the same pattern that we have, 28, 32, and here I'm going to write 10. So after writing 10, then here I'll get, after adding them, I'm going to get, what I'm going to get? I'm going to get 60, isn't it? And the 10 we have. Okay, so 60 minus 10 is going to give us 50. And this is what x union y is equal to 50. So we can see that we have checked and the answer is, 100% correct. So, this is like really easy. But whenever we're going to, whenever we solve a question, like in that question, we're going to it's going to be seen. So it seems like it's really easy. So, just to understand it's a little bit like, first of all, difficult, or maybe like a little bit difficult, but in the question, like we're going to get it directly through the formula. But yeah, we need to understand it, the whatever it is. So this isn't like, we haven't completed practical problems on union intersection of two sets. There's still something remaining, and that we're going to discuss in next video. So that's all for today. See you in the next video, and thanks for watching, and have a great day.